Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this video, we continue the Electrical Grid Explainer series. Let's start off with electrifying the problem. This motor is an electric motor.
This sucker's electrical.
And I want to use it for a project. I don't know what project, but let's get it running. When faced with this problem, an electrician would place the cord down about like this, and then just stare at it. 5 minutes later and try again. As I've facetiously demonstrated here, this motor won't spin, no matter how many times I plug it in. The issue we are having here is that this motor is an induction motor, and for some versions of this machine, it will not work without a crucial system that we as consumers don't get. That system will be explained in detail in the next video in this series. Get subscribed so you don't miss it.
So although we may have an extensively vast and complex countrywide wiring system, it's completely useless until we actually put energy in the system. In this video, we are going to do that with hydropower.
So today, we are going to be touring the Niagara Power Station, and taking a look at how hydropower works. But first, we have to get there. And we are going to be doing that with car.
Now I've been to Niagara Falls several times before, but getting to see inside this place was so cool. When I got in, the first thing I noticed was the Tesla coil. In a hydropower plant, energy is initially generated by building up a massive amount of gravitational potential energy. This is done by physically blocking the water from flowing downstream with a dam. This enormous potential energy is then converted to kinetic energy by releasing it through a series of massive pipes called penstocks. At the outlet of these penstocks, water is released at a very high flow rate in a jet stream directed at a circular device called a turbine. There are a number of designs that a turbine can take depending on input flow rate and output power requirements. Specifically for the Niagara Power Station, the cross-flow design is used due to the limited footprint of the power plant, but in general, the operation is pretty much identical regardless of the design. The high-flow water stream is caught by the blades of the turbine, effectively getting pushed back by the water, which in turn applies a torque to the turbine which makes it spin. A shaft, being rigidly connected to the turbine, spins as well, and in the case of this power plant, the shaft has to travel almost the entire length of the penstock, again due to the limited space inside the power plant. Once it reaches the top of the penstock, it is rigidly connected to the rotor of the generator, producing electricity. I will lean on our tour guide for the rest of the details.
We're going down 180 feet down the tunnel. The tunnel is 2,200 foot long, half a mile or 700 meters. We're going to look out the front window first. That's this one. This is number 1 penstock. That's a 10-foot diameter pipe that takes water down 136 feet to spin the turbine. 80,000 gallons of water flow through that pipe. Out the back window, levels and decks the gentleman used to use to maintain the machine.
Wow.
The only way up and down on these levels are using those ladders.
Oh,
The shaft in the
no.
middle is 135 feet long, and it connects the turbine that's in this housing with the alternator up above. Once all the water spun the turbine, it drops out into the wheel pit. That goes the whole length of the building, 600 feet, takes all the water from all the turbines, directs into the tunnel so it can return to the river. Enjoy the walk. It's a fantastic view at the end.
As you can probably tell, the power station tour was awesome. If you're ever in the Niagara Falls area, then the Niagara Parks Power Station tour is definitely something worth checking out. With the conclusion of the tour, it was then time for Clifton Hill. just toured is decommissioned, with its generation capacity more than made up for by the Serena-backed plant, which also feeds the rest of Ontario. Anyways, guys, I hope you enjoyed the tour of the Niagara Power Station. Hit that like button if you liked it, subscribe if you're new, and I'll see you next time.
Ha! I knew this motor would work.